All right, here we go, guys. We have a few more to convert. And so you can see part E, we have a degree symbols, and they want to go ahead and figure out how many radians that is. So it's 180 degrees over pi radians is equal to negative 225 degrees over x radians. Okay? If we cross multiply, we end up with negative 225 pi equal to 180x. Again, we're solving for x, so we're going to divide by 180. And we're going to go ahead and type this fraction in. Negative 225 divided by 180, math bracket. And that comes out to be negative 5 over 4. But remember, there's pi, okay, on top. So negative 5 pi over 4. And this is in radians. Okay. Let's try the next one. Next one, our angle here does not have a degree symbol, so we're going to assume this is in radians. Okay, so we're going to do 180 degrees over pi radians still, but x amount of degrees over 2.5 radians. Okay, we'll cross multiply and we end up with pi x or x pi, doesn't matter, equal to 2.5 times 180, which is 450. And there's no pi. You can see on this one, radians don't always have a pi in them, although typically they do. But sometimes the pi has been calculated in to the number and been rounded. All right, so in this case, we're going to get a decimal. 450 divided by pi is 143.239, and it keeps going. All right, and if you remember, directions on the other side of the page said round to the nearest degree if necessary. And so to the nearest degree, we're going to go ahead and say 143 degrees. Okay. Next one up, you guys can see there's no degree symbol, and so we're going to assume that this is in radians. And so we have 180 degrees over pi radians equal to x amount of degrees over negative 3 pi over 4 radians. Okay. If we cross multiply, we get pi x equal to, we're going to do 180 times negative 3/4 in our calculator. Okay. And that gives us negative 135. And we have to remember there's pi there because there was a pi in that negative 3/4 that we multiplied by. Okay. In this case, we do have a pi on the left and a pi on the right. And so when we cancel them, we end up with negative 135 degrees. Okay. And last one. There's no degree symbol, and so we're going to assume that this is in radians. So it's 180 degrees over pi radians equals x amount of degrees over 5.8 radians. Okay. If we cross multiply, we get pi x equal to 5.8 times 180 is 1,044. Okay. There's no pi to cancel on the one side, so we'll go ahead and divide by pi so that we end up with x equals 332.315 ... To the nearest degree would be 332 degrees. All right. So hopefully you guys can see how to convert if you have radians and you need to think about it in degrees, okay, or if they're asking for radians. We know how to convert now. Just set up a proportion. Just remember the left side is 180 degrees over pi. All right, number 3, guys, says that an angle drawn in standard position whose radian measure is 2 radians would terminate in which of the following quadrants? All right, so we're going to go ahead and convert because we don't know where our radians really are, especially when they don't have pi in it. So we're going to go 180 degrees over pi radians is equal to x amount of degrees over 2 radians. Okay. We'll cross multiply, we get pi x equal to 180 times 2, which is 360. We're going to go ahead and divide by pi, and x comes out to equal 114.59 ... So now when we think about our graph, and that 90 degrees is here and 180 degrees is here, we know that 114 degree angle will fall somewhere in quadrant 2. Okay. So hopefully that helps. Okay. Number 4, it says that cosine theta equals square root of 2 over 2, and we have to find the exact value of theta in radians. Okay. So what we're going to do is we have to solve for theta. Theta is an angle, and so we're going to go ahead and use our inverse keys. And we're going to type this right into our calculator. Okay. What comes out, since our calculator is in degrees, comes out 45 degrees. However, they want the exact value of theta in radians, and so this is not our answer. That would be our answer for theta in degrees, okay? But we have a way of converting, so we're going to do 180 degrees over pi radians is equal to 45 degrees for how many radians? Okay? If we cross multiply, we end up with 45 pi equal to 180x. And we're going to go ahead and divide by 180 so that we can solve for x. And there's that fraction we're going to reduce, 45 over 180. Okay? And we're going to go ahead and get that theta equals pi over 4 radians, which is equivalent to theta equaling 45 degrees, okay? So these are the exact same answers, just one's in degrees and one's in radians, okay? Just like if they asked for the answer in inches or they asked for the answer in feet, okay? It's just a different measurement, that's all. Number 5 says determine the reference angle for each of the given angles. Express your answer in degrees and radians, okay? So let's go ahead and figure out what 2 pi over 3 is equal to. So in degrees, so that we can go quickest way back to the x-axis and give our answer in degrees. Okay? So we have 180 degrees over pi radians is equal to x amount of degrees over 2 pi over 3 radians. Okay? If we cross multiply, we get pi x or x pi equal to 2/3 times 180 is 120 pi. Pi on the left and a pi on the right, we end up with 120 degrees. So now what we're going to do is we're going to think about where 120 degrees is and draw in our rotation diagram. And so we know that the x-axis is 180 there. And so this is our angle of 120 degrees. They want a reference angle, which is the quickest way back to the x-axis, which would be going this way, and that angle is 60 degrees. Okay, and so there's our reference angle in degrees. Now we need it in radians. So we're going to go back and convert. So we have 180 degrees over pi radians is equal to 60 degrees over how many radians? Okay, if we go ahead and convert this time, we end up with 60 pi equal to 180x. And we're going to divide by 180 to solve for x. And we're going to type in our fraction of 60 divided by 180. Okay, which is 1/3. And so we don't really need the 1 because we have the pi on top. So we'll say pi over 3 radians. And there's our two answers. 1 in degrees in the yellow, 60 degrees, and pi over 3 radians is the conversion. Okay. All right. Part B. We're going to do the same thing. We want to turn this into 2 degrees so we can find the quickest way back to the x-axis. So we have 180 over pi equal to x degrees over negative 5 pi over 4 radians. Okay. When we convert, we have pi x or x pi equal to 180 times negative 5/4, which is negative 225 pi. Okay. Pi on the left, pi on the right, and we end up with negative 225 degrees. All right, but that's what that angle is. So now we're going to go ahead and draw it out. So we have to remember that it's a negative angle, so we have to go down and around, okay? Down and around negative 180, negative 270, so it is in quadrant 2. Okay? This is our angle. I guess maybe I should have drawn it in red. Normally I draw my negative angles in red. So this is negative 225 degrees. The quickest way back to the x-axis would be to go backwards to the 180 line. All right, and so negative 180 to negative 225 is 45 degrees. Okay. And that's our reference angle, except they also want it in radians, and so we'll convert back. 180 degrees over pi radians is equal to 45 degrees over how many radians? And when we cross multiply, we get 45 pi equal to 180x. If we divide by 180, we end up with x coming out to equal, math frac that, and that is 1/4. So we'll say pi over 4 radians. Okay. Awesome. All right, last question. Which diagram shows an angle rotation of 1 radian on the unit circle? So we don't know how much 1 radian looks like on the unit circle, but if that radian was in a degree, we could. So we're going to convert 180 degrees over pi radians is equal to x amount of degrees over 1 radian. Cross multiply, we end up with pi x equal to 180. And we're going to go ahead and divide by pi so that we get x equals 180 divided by pi is 57.9229, and that's in degrees. And so now we know what 57 degrees-ish looks like. It's definitely in quadrant 1 because this is 90 degrees and this is 0 degrees, and 57 is halfway in between there. Okay, this would be a 90-degree rotation. This would be a 180-degree rotation, and this is 360-degree rotation. So it's definitely number 1. All right, guys, hopefully that helps with how to convert from degrees and radians to degrees, okay? We know way more in degrees, so if you're ever given radians and unsure of what to do, convert it to degrees, okay? And then hopefully some things click. All right, I'll see you guys in the next day of notes.